Good morning, everyone. In the last session, we discussed about the list related specific methods here. So we identified list interface. Basically, what is the purpose of this particular list interface here? So it will try to store the elements in the sequence order. Okay, this is very important. We need to understand here. Whatever the list interface we are discussing here, if I want to implement anything, first we need to understand the purpose here. If anything we are going to implement here, it will try to give you the option. Basically, it will try to provide the element in the sequence order, like how we are going to insert the same element, like we are going to get the same elements here. Okay, so this is one of the important example, like this particular list interface is going to provide. Now what we need to understand here, so these are all the some specific method we are having from this particular list interface. Now you can see, so boolean add all and get method, set method, add method, as well as, so what we need to understand here, remove method, something like index of, lost index of, list iterator, and internally it is expecting the overloaded method called list iterator one index here. Okay, and another one sublist. So this is we discussed about in the last session, something like a substring. How we are going to write the substring? Same way it will try to give you the sublist information. Okay, same way it will try to give you the sublist related information here. Now what we need to understand here, and today we'll discuss about the abstract list. One of the important class where we need to discuss first, something like abstract list here. Abstract list. Okay, so if I'm going to open this particular abstract list, now you can see it is extending from abstract collection. So yesterday we discussed some of the methods are implemented and some of the methods are not yet implemented inside this particular collection. Okay, so whatever the methods are not implemented, the method will carry forward to this particular abstract list. Okay, now you can see it is implementing which interface here. It is trying to implement the list interface. Getting the point. Now if you see this list interface internally, it is trying to extend from the collection interface. Okay, so now you can see this is the list interface. Internally it is extending from the collection interface. So this is very important. As of now, what is the hierarchy we are discussing here? Something like first one, collection. Okay, and collection internally it is extending from this particular list interface, and same way collection internally it is extending from the abstract collection. Okay, and abstract collection internally it is extending from the abstract list. Getting the point? So see the hierarchy, how this particular hierarchy right now we are implementing it. So this is something like here we are using extends here, and here we are using implements here, and here we are going to use again extends. Okay, this is one of the important example we need to understand here. So something like interface to interface we are using the extends, and interface to one class we are using the implements here, and class to class internally we are trying to use the same extends here. Okay, so compare this hierarchy right now. Now we'll try to add more classes and more interfaces on this. Okay, this is important we need to understand here. Let me move on to this particular abstract list. Okay, so as we are discussing here, it is extending from this particular abstract collection and it is implementing from this particular list interface. Okay, so now what I will do here, I'm going to write the some of the what are the classes. Now you can see add method. This particular add method is coming from the which interface? It is a collection interface because it is trying to return boolean value. So if you see this, the add method is expecting two parameters, and here now you can see it is expecting only one parameter. But internally, now observe carefully, it is trying to call the two parameters add method. Okay, it is trying to call the two parameters add method. So first parameter is calling the size, second parameter is trying to call as a element here, whatever the element we are passing, and it is internally returning true. Okay, it is internally returning true. So because whatever this add method is coming from the collection interface, and this particular add method now it is coming from the list interface. Okay, so we are calling both method internally, and this is the abstract method they are making for this particular get purpose, and set purpose, that this is the default one. We are trying to throw in a exception, unsupported operation exception. Okay, so this is also we need to implement this. And add method, this method is also we need to implement. Just here we are throwing the default information, but this is not the correct one, we need to write. So and now you can see the remove method also, it's throwing an exception. So index of, okay, whatever this particular index of we are writing here. Now what we need to understand here, now observe carefully. This is something like if you give the object internally, it will try to find out the index information, where like in the which index location this particular object is resides here. Now you can observe like a list iterator we are finding here. If this particular object is null, this is the code is going to execute, but most of the cases will not going to give null, and we'll need to check for this particular else section. So and this is the it dot has next here. Okay, so something like a list iterator we are calling here, and we are calling the, if we are having a has next here. Now what I will do, I'm going to check this particular object. I'm going to check this particular object here. Now, so once this particular object is will contain, now what we are doing is we are trying to find out the previous index here. Getting the point? So we are trying to find out the previous index. So this is the index of here. Okay. So what I will do, I'm going to provide this particular method implementation one more time whenever we are discussing about the implementation classes here. Okay. So but what we need to understand here, so whenever we are calling this particular index of, finally what is the method we are calling? Previous index. Okay. Previous index. So we discuss here previous index and next index. So because of this particular list iterator, we are having an option to call this particular previous index. Okay. So same way, if anything not found here, this condition and this condition will fail, it will try to return as a -1. Okay. It will try to return as a -1 here. Now another one, last index of. Last index of, now you can see we are calling next index, and index of we are calling previous index. So this is only the differences here. Now observe carefully another method here. So clear method. Clear method basically what is doing is remove range here. So internally we are calling the remove range method based on this particular values here. Based on this particular values, it will try to remove the elements. Now you can see what is the range we are giving, 0 to size. Size is nothing but right now how many elements we store into this particular collection. So all the particular size will give you the, so something like we are trying to remove the all elements which are available inside this particular collection. Okay, so collection nothing but list. Now add all method. So add all method, again we are calling the for loop, and internally we are calling add method. But now what we need to understand, we are increasing the index. So how many records we are going to have, based on that it will try to increment the index. Here we are trying to call this particular index plus plus. So something like this particular index is keep on increasing based on this particular loop iteration. Okay, so this is we identified. Now iterator and list iterator, and so we are having one more list iterator with expecting one parameter, and internally now you can see it is a nested class. Okay, so this is the one of the private class we are defining ITR, and it is implementing from this particular iterator. Okay, so these are all the, for something like last index cursor related section they implemented this, so we don't need to discuss about this particular ITR. Now we'll move on to the list iterator also. So we have two nested classes, and internally they are calling the add and set method. Now you can see sublist. This is we discuss about this particular sublist here, what exactly the sublist is doing it, and based on this particular range, the from index and to index, it will try to create an object, and it is trying to call the constructor information. Whenever it is calling this particular constructor, what happens internally, it will copy the elements and it will come up with this particular list object here. Okay, so we'll discuss about the remaining method whatever we are having here. Now observe carefully. We identify the list interface, and list interface is having these are all the specific information. Okay. Now what I will do, I will move on to the another important section called set here. Okay, set interface. Now what we need to understand this particular set interface here. So set is internally it is extending from this particular collection, and basically this particular set interface it will not allow the duplicate elements. Okay, it will not allow the duplicate elements. So finally again this particular set extends from the collection. Getting the point. So this is the another important interface we are discussing here. Now let me write let me show you this particular set interface. So now you can see this is an interface, set interface. It is extending from this particular collection. It is extending from this particular collection. So size method. So I will try to catch up the collection related method first here. Size method we are having, and is empty method, and return type also boolean. Okay. Now contains method. Okay, iterator method we are having, and to array. Okay, so this is the another to array method we are having, add method. Okay, so remove method, and something like contains all. Now you can see where is the contains all. Contains all. It is trying to expecting boolean type here, and add all. Okay, add all we are having. So finally retain all. Whatever the method we are having, so it will have same type here. Each and every method which is coming from the collection interface. So equals and hash code, and this is the default method. So default method we may come up with a different value, but the all the abstract methods. So for whatever the abstract method we are having, all the abstract methods will come from the collection interface. Okay, so directly we can write here. Directly we can write here inside this particular set all the methods. Okay, all the methods I copy from the collection interface. I'm trying to add into the set interface. So this is the off method. Okay, this is the off method I discussed from the 9 version onwards. Getting the point. I'm trying to discuss about this particular version 9 version onwards here, and these are all the off methods. So this we discuss in the list interface also. Same. Okay, off is a overloaded method. It will try to expecting multiple values. So earlier now you can see it is added 5 parameter. Now it is added 6 parameter. Okay, so added 7 parameter also, and 8 parameters also it is added, and 9 parameter also it is added. So observe carefully. So it's keep on increasing up to 10. After this, what happens internally? This is the var concept. Okay, the var concepts also we discuss here. Now you can see this is the var they implemented here, and finally copy of. Okay, copy of one method is there. It is a static method. So directly with help of this particular set.copy of we can call. Because of this particular static we discussed in the last example how we can call. With help of this particular interface we can call this particular copy of method. Now exactly it is doing, it is trying to call the set.off, or now you can see whatever we are having this particular abstract immutable set, it is returning this. So we'll try to debug this particular section and we'll see how it is working internally. Okay, so this is all about this particular copy of method. So there is no specific method inside this particular set interface. So whatever we are discussing here, all the interfaces, all the methods are coming from the collection interface. Okay, this is the one another important interface, something like set interface. And I'm trying to discussing another important interface, something like a sorted set. Okay, sorted set basically internally it is extending from the set interface. Okay, this is Very important. Now observe carefully how the hierarchy we are having as of now. So sorted set internally, it is extending from this particular set interface. Okay. What exactly the sorted set will do? If I'm going to open this particular sorted set here, sorted set. Okay. And now you can see this is also coming from the 1.2 sorted set. Internally, it is extending from this particular set here. Now, here we are understanding comparator. Here we are understanding one method called comparator. Okay, we'll discuss about this particular comparator. First, what we need to understand, what is the purpose of this particular sorted set here. Now you can see, so here we need to understand this particular sorted set behavior, what exactly it will do here. Okay, so based on this particular ascending or descending, we are going to use this particular sorted set here. And now you can see, what is the type we can provide. So the elements basically, the elements are ordered using their comparable nature ordering. Getting the point? So whatever the elements we are going to write inside this particular sorted set, so based on this based on this particular ordering, the elements we are going to get as a order here. Okay, and now you can see typically we'll call it as a sorted here. Okay, so we'll call it as a some sorted order. So we have a two types of sorted, ascending or descending order we are going to use. That ascending and descending, it will try to work on the based on this particular comparator. Okay, so based on this particular comparator, it will try to provide the some sorting behavior. Okay, we'll see the what exactly the sorting behavior we are going to get. So now what you need to understand, what exactly this particular interface will give you the information based on the some sorting behavior. So first, the method we discuss here, comparator. Okay, this is the comparator we are having internally. It will try to provide the wildcard type like this here. So here we are having, it should be the super of this particular whatever we are going to provide the wildcard. Now you can see comparator we are having it, and it is a one of the functional interface. So it's contain only one abstract method. Okay, now you can see compare, getting the point. So it's going to call this particular compare method, and it's a two argument for this particular order. So this particular comparator is expecting two parameters for this particular order, and it will try to return the negative integer, 0, and a positive integer. So it's something like -1, 0, +1. Okay, and so now you can read this. First argument is less than. Okay, if the first argument is equal, or first argument is greater than to second one. So if it is less than, we'll get as a -1. If it is equal, we'll get as 0. If it is a greater than 1, we are going to get as a positive values. Okay, now you can see positive integers. So this is the purpose of this particular compare method. Where the compare method is we are having. So this is the compare method. Now you can see it is expecting two values. Okay, it is expecting this particular two values. So this is the abstract method we are having. Now you can see default method we are having, and one more default method we are having. So some of the all the default methods here, but only one abstract method we are having. Getting the point? So this is, we need to understand very carefully how this particular comparator is going to work. Okay, so we'll come back to this particular comparator. We are identify what are the information we are having. Now we'll move on to the another information. Now you can see subset. So subset. So we discuss about the sublist. Same way we are going to call the subset, and finally it is trying to return the type called sorted set. Okay, the name of the method it's saying as a set here, but the return type it's trying to return the subset information. So something like the same thing what we identified in the sublist here. Same way it will try to create the, based on the range, it will try to create the object here. Okay, so based on range, this new sorted set object is going to create it. Now you can read this. So return the view of the portion of this particular set. So we like whose elements range from element to, and it includes the two elements as well, because these are all the important conditions here, from and to 2. Okay, these are all the important elements we need to understand, from and to 2. Based on this particular range, so it's going to create the new sorted set object and it will give you the information here. Okay, and this is the subset we identified and head set here. So this is very important. Whatever the specific method we are having, now observe carefully what exactly it will do this particular head set here. So now we need to read this. Okay, again, this particular method will return the same sorted set object here, and you can read this whose elements are strictly less than to this particular 2 element. Okay, whatever the 2 element we are having, so something like this, whatever this particular element we are going to provide, and it will try to check internally less than to this particular elements here, and whatever the elements we are going to match less than to this particular condition, so those elements are going to return by this headset method. So and internally it will try to throw in some exceptions here. So first one is class cast exception and null pointer exception and illegal argument exception. Okay, so we'll identify this particular headset. What is the purpose of this? So it's something like it will try to come up with a less than condition. Okay, so based on this particular less than condition, it will try to return all the values here. And so one more method we are going to have tail set. What exactly this particular tail set will do? Now you can read this greater than here. We are using this greater than or equal. Okay, so here we are using the condition greater than or equal. So something like the headset method. Okay, headset method basically it will try to return the less than, and the tail set method basically it will try to return the greater than or equal. Okay, greater than or equal. Okay, so this is all about the tail set here. Now finally, first. Okay, first method. What exactly the first method it is doing? Now you can see return the first lowest element. Okay, so internally it is trying to return the lowest element from this particular set here. Getting the point. Now we need to understand how we are making the condition for this particular lowest here, and for this particular last we are going to get as a highest. Okay, these are all the static method we can call here. Okay, and now you can see the same element it is trying to return here. So because now we need to understand very carefully, because of this particular generic here, now we are trying to returning multiple times the particular element here. And another important section, default method. Okay, so this is something like iterating the values here. We'll discuss about this particular split iterator. But how many methods we are having inside this particular sorted set here? First one is a comparator, second one is a subset here, and head set, and tail set, first method, and last method. So around 5 specific methods are available inside this particular sorted set, and the remaining methods we can use from this particular set interface. And finally, the set interface methods are inheriting from the collection interface. Okay, so if we observe the hierarchy, how this particular hierarchy we are having, first one is collection, and here we are trying to discuss about the list interface, and here we are trying to discuss about the set interface. And set internally it is having sorted set. Okay, so another way, here we are trying to discuss about the abstract collection, and abstract collection internally it is extending from the abstract list, and abstract list finally it is implementing from this particular list interface. Finally it is implementing from this particular list interface. Okay, so if I'm going to provide the abstract set related, so first we'll identify whether do we have any abstract class for this particular set also. Okay, now you can see we are having abstract set. So what exactly this particular abstract set is doing internally? Now observe carefully. Abstract set internally it is extending from this particular abstract collection, and it is implementing from this particular set interface. Okay, so any collection, the abstract classes are extending from this particular abstract collection, and any interface it is trying to extending from the collection interface. Okay. Now, if you identify, so equals method is implemented, hash code is implemented, and so remove all method is implemented. Only three methods are implemented inside this particular abstract class. Only three methods. So remaining methods we did not write here because of this particular abstract. So no need to write any the abstract methods here. Okay, this is very important example. So we discuss about this particular abstract set. So nothing like there is no much important concept inside this particular abstract set. So finally, what we need to understand here, sorted set. So the sorted set we identified now. Now navigable set. So this is the another important interface. This is the another important interface here. So navigable. Okay, navigable set internally it is going to take same, and it is trying to extend from the sorted set. Okay, so this is very important, we need to understand. It is extending from the sorted set. So whenever it is extending, again this method we can use. Whatever this particular five method we are seeing here, so this particular five methods we can use inside this particular navigable set, and any specific method we are having, any specific method we are having inside this particular navigable set. No, here I need to write navigable set. So it is trying to extending from this particular sorted set. So when it is introduced here from the 1.6 onwards. Okay, 1.6 onwards it is implemented this particular interface here. Now these are all the specific methods. Lower method. What happening internally? It is trying to return the greatest element in this set, and now you can see it will try to identify the strictly. Okay, it will try to identify the less than the given element. Okay, less than the particular given elements. But what we need to understand basically some differences, because if you see here we are having headset here. Okay, headset also will do the same purpose. Here also it will try to return the less than condition. Based on the less than condition, it will give you the sorted set here. And here, so this is also it is trying to give you the same less than condition. Okay, so less than condition. And if based on this particular code is not matched here, it will try to return the null. Okay, it is trying to returning this particular null whenever there is no such element here. Okay, but inside this particular sorted set, again we need to go to the sorted set, and what is the method we are discussing? Headset method. Now if I am going to explain this, we need to read one more time. The return set is back to this set and change the return to somewhere. Now you can see the return set will throw an illegal argument exception and attempt to insert our element outside of this particular range. Okay, getting the point. This is important here. Now, whenever we are calling this particular headset method, if the element is not available within the range, we'll get an exception. Okay, we'll get an exception. But if I'm going to explain this particular navigable set here, it will return simply null here. Simply, it will null here. Okay, getting the point. This is the important information we need to understand between these two methods. The headset method will throw an exception based on the condition if the condition is not satisfied, but the lower method will not throw any exception. It will try to return the simply null value. Okay, so this is the lower method. Same way we are going to have floor method. The floor method, what is doing it? Now you can see, so here we are having less than or equals to this particular given element. Okay, less than or equals to this particular given element. But here we are going to make only strictly less than here. Okay, we'll make a strictly less than condition. So this is the another important method we are having, something like a floor method. Okay, so floor method we identified. So now you can see this particular, the ceiling method, it is trying to take as a greater than or equal. Okay, greater than or equal. So if you observe, based on this particular greater than, less than, we are having some different methods inside this particular navigable set here. Inside this particular navigable. And here we can make greater than or equals. Okay. Or we can make something like a greater than. What about this particular? So strictly we are going to make less than or equals to something, or we are going to make as a less than. And this is basically simply less than condition. Simply less than condition. Okay. And higher. So we are having higher method. And here we are going to discuss about the strictly greater than here. Okay, strictly it is a greater than. Now if I'm going to write this particular higher method, so only it will have the greater than. So there is no equal condition. Okay, there is no equal condition. So we want to move on to the equal condition. We can call this particular method, or I want to check only greater than condition. We can go for this particular. We can go for this particular higher. And now you can read this. So one more method we are having, pull first. What exactly it is doing internally? It will try to retrieve and remove the first lower element. Okay, it will try to retrieve the first element from this particular navigable set, and the first element is going to remove here. Getting me? Now you can see it removes the first. First is nothing but lowest element here. Okay, and it will try to remove the lowest element. Finally, what we need to understand here, and it will return whatever the element it's going to remove. Okay, what is the element it's going to remove? The particular element is going to return here. This is important here. So getting the point. So some different method we are going to find inside this particular navigable. So what exactly the navigable set will do? And basically getting the point. So basically it's going to support the retrieval operations based on the closest match here. Based on this particular match, it will try to retrieve the specified element here. Okay, because of that we are having different methods here. Because of that we are having different methods. Now you can see, so retrieve and remove the first element, or it will try to return the particular element here. Now observe carefully, here I'm trying to write the pull first here, and another important method, pull last. So what exactly the pull last will do? It will try to return it will try to remove the highest here. So here we are having lowest here, and it will try to return the highest here. And we are discussing about the iterator. So no need to write this particular iterator here. And so descending set here. Now you can see navigable set is trying to returning. And what is the name of this particular method? Descending set and descending iterator. So first we will discuss about the descending set, what it will do. So returns the reverse order. Getting the point. It's trying to return the reverse order. So when this particular contain this particular set, whenever the elements will inserted into this particular navigable set, if I want to get any reverse, if I want to get any reverse order, what we can do? We can go for this particular descending set here. Okay, and finally, what happens internally? What happens internally? They are going to call collections reverse order. Okay, collections reverse order we are going to call. Now you can see collections reverse order method we are having, and the particular reverse order method will do the descending order here. Okay, we'll discuss about the how this particular reverse order will contain internally. So why I'm writing these many methods? Because we'll try to debug the code, how this particular code is implemented, because at the time we cannot discuss about the purpose here. The purpose here only it is trying to giving the information. So each and every method, so we can easily understand the purpose. But what we need to do, we need to understand how these particular methods are implemented. Then only we can come up with our custom any one of the collection class here. Okay, so we discussed like one of the array concept, we discussed the dynamic collection, and the same way we can write based on the different methods here. And now you can see descending iterator. So something like it will try to provide from the reverse order, the elements we are going to get in the reverse order. Getting the point? It will try to return the iterator over this particular element in this set, but here the observe basically in descending order. Okay, So instead of getting the ascending order, basically, whenever you are calling descending iterator, it will try to return like it will try to come up with the one by one elements in the reverse order, here. So this is very important method we are having inside this particular navigable set. Navigable set is nothing but what is the purpose? It will try to provide the behavior of this particular collection. What is the behavior of this particular collection? It's going to provide retrieval elements. Getting the point? Based on the nearest match, based on this particular nearest match, it will try to provide the elements. Okay, so we'll read the purpose of this particular interface type once we completed this particular methods information. So now you can see subset we are having. Okay, this is the one of the important subset. But now read this. We are having 4 parameters and 2 parameters we are having as a element type. 2 parameters we are having Boolean values. So we don't need to discuss about this particular 2. We need to discuss about this particular from include and to include. What exactly it will do? This is important here. Now you can see if I'm going to provide this. Now you can read this. What happens internally? So if from element and 2 elements are equal, okay, the return set is empty. And here what we need here? So here we need to understand here from inclusive and clue inclusive are both true. The return set is backed by this, so where they implemented. So basically, it will try to give you the basic information. I want to return the current element so that we can move on to this particular inclusive. Okay, so right now, ignore this. We'll try to implement this section whenever we are trying to identify the implementation classes here. So what exactly this particular parameters are doing here? What is the parameters here? From inclusive and the second one is the to inclusive. These are all the Boolean parameters. Okay, now you can see one more. We are having headset. Headsets is something like based on the some less than condition, we are going to return the element here. Okay, so based on this particular less than, and now you can see this particular method will throw an exception. Whatever the headset method we are implementing it, this particular method will throw an exception whenever the element is outside of this particular range here. Okay, if the element is not matched to the condition, we are going to get an exception here. Getting the point? So now you can see the same thing we are going to get the whose elements are less than. So based on this particular less than here, it will try to return the navigable set information. So something like this is also one of the subset here, but we are checking the condition only less than condition. So there is no range here. There is no range here. So just we are going to check for the less than. So same way we are going to have greater than condition. So this is we'll discuss about the greater than here because it is a tail set where we define the tail set here. So inside this here head set and tail set. Inside this particular sorted set, whatever we have discussed the head set and the tail set, the same methods are implemented here, but here it is expecting 2 more parameters. Like additional 1 parameter, it is added inside this particular navigable set here. So subset here. Okay, this is the same subset we already discussed in the sorted set here, and head set. This is coming from the same sorted set methods here. Now you can see subset is returning the sorted set, and head set also it's returning the sorted set, and tail set also it is trying to return the sorted set. And now you can see whatever the method is expecting 2 parameters, it is not returning the sorted set. It is trying to return the navigable set here. Okay, so these are all about the important method we are having inside this particular navigable set here. Inside this particular navigable set here. Now, what we need to understand here, now you can see, so this particular class, this particular interface, it is extending from this particular sorted set here and with a navigation method reporting. Getting the point? So navigation purpose, we are going to call this particular navigation set method, and it will try to return the lower method, floor method, like ceiling method, whatever we are discussing, higher method. And these are all the return the elements respectively less than and less than or equals. Getting the point? Equal, like getting the point, less than or equal, greater than or equals here. and some code they are trying to return the null also. Whenever we are does not have any the satisfied elements, it will try to return this particular null values. Now you can see, so basically it will try to move on to the axis. Now you can read the second parameter, ascending or descending order. With help of this particular navigable set here, the elements we can move based on the ascending or descending order, because we identify descending set and descending iterator. So it will try to return the reverse format. Okay, and it's trying to providing the different methods information. All the method we discuss here. Now I will move on to the one of the last like we have two more interfaces we need to discuss. Queue interface. Okay, queue interface. So now if you see the hierarchy, how we are having collection and list we are having. Okay, and this is the set we are having, and internally we are having sorted set, and the sorted set we are having navigable set. So this is the set hierarchy. Now I am going to discuss about the one more queue here. Okay, let's observe the how this particular queue interface is defined here. Now you can see, so this is the one of the queue interface. Now it is extending from this particular collection, and insert the specify element into this particular queue if it is possible immediately without violating the capacity restrictions. Now what you understand, basically without checking this particular capacity related, we can insert this particular element into this particular queue. So that is the method we are going to do, the add method. Okay, now you can see offer method. So this is the offer specific method we are having, remove method and poll method. So how many methods we are having? Around 5, 6 methods. These are all the another interface we are having. These are all the another interface we are having. So now observe carefully. We'll try to identify what exactly this particular queue interface will do. What exactly the queue interface is doing. So now you can see a collection. So designed for holding the elements prior to the processing here. So here only the particular each and every interface we can identify what is the purpose of this particular interface will do internally. Okay, so queue provide the additional insertion, extraction and inspection operations here. So now you can see what are all the specific method we are having inside this particular queue. So what we need to understand, first in, first out. So this is the FIFO model we are going to use whenever we are trying to discuss about the queue interface basically. Now observe carefully. The first method we identified here, something like add method. So what it will do, this particular add method, it will try to add the element into this particular queue. It will try to add this particular element into this particular queue. So now what I want to write, this particular queue internally is extending from the collection. Okay, and the first method I'm trying to add something like add method. So whenever it is extending from this particular collection, whatever the method we discuss in the collection interface, all the method we can access into this particular queue. Okay, and another one, offer method. What exactly this offer method is doing it? So what is the difference here? Add also returning true, and offer also it is returning true. Okay, what is the differences here? Now we need to understand here, basically it will try to insert the specified element into this particular queue, and if it is possible to add the immediately without violating any capacity restriction. So it will have the same here. So this message will also same. So capacity restriction and returning this particular true. Okay. So whenever the element is success, whenever this particular element successfully added into this particular queue will return true. Otherwise, it is throwing an exception called illegal state exception. Getting the point? Here only we can read this information. The add method will throw an exception. Okay. Now you can see offer method. What happens internally? Now you can see. So here we need to understand here, when using the capacity restructured queue, this method generally preferable to link add, which can fail to insert an element only when throwing an exception here. But basically, it will not throw anything. So it will return the false here. Okay. If the element is added into this particular queue, it will return true. Otherwise, it will return false. But add method, it will not return any false here. It will not return any false. Now it will directly will throw an exception here. Now you can read this. You can read this particular line. We can easily understand here the differences between add method as well as offer method here. So it will throw an exception in the add method, but offer method it will not throw any exception. Just simply it will try to return the false here. And remove method. So no need to discuss about this particular remove method. Basically, the remove method, what it will do, it will try to remove the elements from the particular queue. Okay. Now you can see, but it is not expecting any parameters here. So, and it is going to retrieve the element and remove the head of this particular queue. So now you can see this method will different from the pool. Getting the point? This particular method is different from this particular pool. But what we need to understand here, it will try to throw an exception. It will try to throw an exception when the queue is empty. So this is important. We need to understand when we can call this particular remove method. Whenever we are having elements inside this particular queue, then only we need to call this particular remove. Otherwise, we'll get this particular exception here. Getting the point? This is important here. So now if I'm going to write this, so this is also, it will try to remove here. Now you can read this. It will try to remove the same element from this particular queue, but it is returning null whenever the queue is empty. And whenever the queue is empty, it will throw an exception. Getting the point? So see the differences here. The differences between remove method as well as this particular pool method. So pool also internally will delete the object from this particular queue. Okay, and another one is element. Now we can see the element method is going to match with this particular peak method, but the element method is trying to throw an exception. The peak method will not throw an exception. Okay, so now just it will try to retrieve the element, but it will not remove the element. Getting the point? So this element method, it is going to load the element, but it will not remove the element from this particular the queue collection. Okay, and if the element is like, if the queue is empty, we'll get an exception here. Getting the point? And the final method, something like the peak method, what we need to understand, same thing, it will try to load the element. So if the element, like queue is empty, it will try to return null. It will try to return null. So these are all the important method we are having inside this particular queue. So what is the purpose of this basically queue? First in, first out here. Getting the point? So this is for first in, first out here. Okay. So this is very important to the interface we are discussing, something like a queue. Now understand here another important information, something like a DQ. So when this particular interface is added, now we need to go to this particular version. Now you can see from 1.5 onwards, this particular queue interface is available. And another interface, this is the queue is extending from this particular DQ. Let me provide this particular method information DQ. Now you can see, so this is also introducing from the 1.6 onwards, and it is extending from this particular queue interface. Okay, it is extending from this particular queue interface. Now, whatever the method we have discussed so far here, all the methods are applicable into this particular DQ also. Getting the point? And so this is basically what exactly it will do, and it will try to do the bi-directions operations like first in, first out, last in, first out. Getting the point? So it is some additional behavior we are going to get whenever we are trying to work with this particular DQ interface. Now we'll identify what are the specific methods here. So something like add first method. Okay, add first method. This is the specific method. This method is no longer available inside this particular queue. Let me write this particular DQ and is extending from this particular queue. Okay, it is extending from this particular queue and I'm trying to write this particular add first method. I'm trying to write add first method. So what exactly it will do? Now you can see it will try to throw an element, like it will try to throw an exception if the element cannot be added into this particular time due to the capacity restrictions here. Getting the point? This is important here. Whatever the element we are trying to add, if the element is not added, we'll get an exception. So what is the method name? Add first here. So basically it will try to insert the element. Okay, it will try to insert the element at the first, like at the front of this particular DQ. So something like it will try to move on to the first element here. Okay, so this is all about the first element here and last element. So add last method. So what exactly it will do? The add last method, it will try to insert the element in the last of the DQ and the same thing, it will throw an exception. Okay, it will throw an exception. There is no return type. The two methods we are having void here, but basically internally it will try to check on the capacity. If the capacity is no longer matched the condition, it will throw an exception. Along with that, we'll throw these many different exceptions here. Okay, so we'll try to discuss about the one by one method whenever we are trying to discuss about the implementation. Now you can see offer first. Offer first. What is the differences we are having? What is the differences here? Now you can see, so insert the specified element at the front of this particular DQ. Okay, and finally it will returning the false here. It is not going to throw any exception. The offer first method, it is trying to return the false. True or false it will return. But if you say this, the add first method also is doing the same behavior. It is trying to add the front of this particular DQ, but it is trying to throw an exception. But offer first method, it is not going to throw like this. Just simply, it will try to return the false here. If the element is not added, it will try to return the false. So same way, another method we are having, something like offer last. So this is also same. The offer last method will do the same behavior. It will try to add the element last of this particular DQ. Okay, it will try to add this particular element here. But finally, it will not throw any exception. Simply, it will return the false. Okay, simply it will return the false. Now again see, remove first. This remove method will throw an exception. Same way, this remove first method also will throw an exception. Okay, so what is the nearest method? So we can call it as a pull method. So now I'm calling this particular remove last. Basically, remove first and remove last method, what it will do? It will try to return the, it will try to remove the first element. Okay, if the first element no longer available, it will try to throw an exception. Okay, same thing, the last also. If the last element is no longer available, it will throw an exception. So, and internally, we need to discuss about this particular full first and pull last method. What exactly it will do, this particular pull first and pull last method? So now you can see it will return null. It will return null whenever the DQ is empty. Same thing, this particular pull last also, it will try to return null. It will not throw any exceptions here. So these are all the very important methods we need to understand. Some of the method will throw an exception. Some of the method will not throw an exception. Simply, it will try to return the null values. So now you can see get first. Get first. Again, the get first method will throw an exception. Okay, get first method will throw an exception. Same way, get last method also, it will try to throw an exception. And same way, peak first. The peak first method is not going to throw any exception. Simply, it will return null. Same way, this method, the peak last method also will not throw any exception. Simply, it will return false here. Simply, it will return false. Now you can see remove first occurrence. Remove first occurrence here. This is important here. And now you can read this. So based on this particular objective, if it is satisfied the first occurrences here, it will try to remove this. Getting the point. This is one of the important example we need to understand. We'll discuss about this particular method, how it is going to call internally. Getting the point. How it is going to call internally, we need to discuss this. And same thing like last occurrence. Okay, same thing like this particular last occurrence here. And these are all the queues method they are providing. So now you can see this particular comment section. Now all the queue methods. So we don't need to discuss this particular queue method because add method, offer method, remove method, and pull method, and element method. So getting the point. These are all the specific method which we discussed inside this particular queue interfaces. These are all the same method again added into this particular DQ, because DQ internally it is extending from this particular queue interface. Okay. So far, what we did here, just we identify all the methods here. Okay. Just we identify what all the methods we are having inside this particular collection and what exactly the each and every method purpose is here. So finally, I'm trying to write the class like interfaces here. But now we'll move on to the abstract classes. Abstract classes. Okay. So we discussed about the abstract collection, abstract list, and abstract set, and we'll move on to the abstract queue. Abstract queue. Now you can see this is the abstract queue we are having. Now what exactly it is doing here? Now you can read this. Abstract queue is internally extending from this particular abstract collection and is implementing from this particular queue interface. Okay. So this is the abstract queue we are having. Now what are all the classes is implemented? So it's calling add method. Finally, internally it is calling offer method. Okay, offer method. If the offer is returning true, it is returning true. Otherwise, it's throwing an exception. It's throwing an exception. Now you can see we discussed this particular method here. Some of the method will throw an exception. Some of the method will not throw. So same thing like here they are trying to throw an exception. Explicitly they define the keyword throw new illegal state exception. Getting the point. This is important here because each and every concept we discuss, we don't need to worry about the what exactly the method is doing internally. By seeing this particular internal the method, we can easily understand what exactly the internal method is doing. Now you can see remove method. The remove method, what we are doing is we are calling the pull method, and if the pull not equals to null, whatever the pull method is written by the element here, if it is not equals to null, we are returning the x value. Otherwise, now we are trying to throw an exception. Okay. Now we are throwing an exception. If the if condition is not satisfied, else section there is no return value. There is no null value something. Just simply we are throwing an exceptions here. Now this is also same thing, element method. Getting the point. Now whatever the method we are discussing, this particular method, internally it is calling the whatever the method is not going to throw any exception. Getting the point. And finally it is trying to throw an exceptions information. So clear method. Okay. So this is the clear method we are having, and add all method. So it is coming from the collection interface. Okay. Now you can see if C is a null, we'll throw in a null pointer exception, and C equals to this, we'll throw in a illegal argument exception, and if this particular both conditions not satisfied, we are looping this particular for loop, like it's like a for each loop here, and we are trying to call internally add method. So these are all some of the methods are overridden inside this particular abstract queue, and some of the methods are not yet override here. Okay. So now we need to understand this particular abstract queue we identified. So we need to see the full implementation classes. So far we discussed about the interfaces as well as abstract classes. Now we need to move on to the what are all the implementation classes here. Okay, what are all the implementation classes we are having here? So before going to discuss about this particular the implementation classes here, so one more time I'm trying to define the hierarchy. So now observe carefully, because this is the topmost interface, and here we are having list here, and internally we are having one more something like a set here, and another one we are having something like a queue. Okay, and so list internally, what happening internally is extending like a abstract list here. Okay, and is trying to implement this keyword abstract list, and is implementing from this particular list. And these are all the three we are going to use extends keyword. And sorted set, SOS I'm trying to write sorted set here, and internally navigable set. And all this particular set internally is implementing what is the class we discuss here, something like abstract set here. Okay, and queue internally is extending from the DQ. And what is the abstract class we are having, something like AQ, abstract queue. Okay, and we are going to use the keyword called IMP, implements here. Getting the point? These are all the basic hierarchy we need to understand here. So this exactly the right now whatever we discussed so far here. Now I'm going to add implementation classes to each and every interface. Again, we'll have a different implementation classes. So this is like this. Okay, and here also, so it is going to something like look like here, because from the abstract classes only, it's going to extend from the particular concrete class like fully the implementation class, and finally it is going to implement like this here. Okay, we'll try to discuss about the one of the implementation classes. First, I will start with this particular list here. Okay, so what exactly this particular list will contain, we need to understand here. Now, let me write this particular section. So before going to write this, I'm trying to copy this same, and here I'm going to write. So here we are having inside this particular collection framework. Now I'm going to write the one class here. So what is the class we are having here? Array list here. So let me delete this. So first class I'm going to discuss about the array list here. Okay, array list demo I'm trying to write here, and inside this particular array list demo, first we'll discuss about the how this particular array list is implemented internally. Okay, how this particular array list is implemented internally. First we'll try to focus we'll focus on the implementation methods here. Implementation methods. So before going to write array list here, now it is a generic type. Whatever the generic type we are going to provide, based on this particular generic type, it will try to create a object and it will try to provide the information. So here I'm going to write a string here. Okay, the generic type I'm giving as a string, and I'm going to write as a AL array list here, and array list. So how many constructors we are having? So one is a default constructor, another one is expecting one more collection, and another constructor int capacity. Okay, so far how many constructors we are having? 3 constructors. Default one, explicitly we can provide the initial capacity, and one more constructor which is expecting collection. So one more constructor, basically we can add the collection information. So first I will call the default constructor. First we will see the default behavior. Later we can move on to the remaining information. So first I will go to this particular class. Observe carefully, abstract list is coming from the 1.2. Okay, and is internally extending from this particular abstract list, and it is implemented from the particular list interface. Okay, we'll discuss about this particular interfaces later. Now observe carefully, random access, clonable, and serializable. Okay, so if I'm going to open this particular random access, any information we are having? Nothing. So this particular interface is a marker interface. Getting the point? So this section does not contain any methods. So we discuss about the marker annotation. So there we are not going to write any information same way. We are having marker interface here. So now you can see it is a marker interface. Getting the point. So now what exactly it is doing? This particular implementation is indicates that they support the first the retrieval operations here. It's something like a random access here. Getting the point. So we'll see this particular random access interface, how it is going to work, because nothing is there inside this particular random access. Now, if I'm going to open this particular clonable, now what you understand this is also one of the marker interface. Okay, now you can see nothing is there just for the cloning related section. Now you can see object.clone. Whatever the object.clone method we discussed in the earlier example, same thing if you are trying to clone, this clonable interface is going to use here. Okay, so serializable. What it will do this particular serializable? So something like right now, we don't have any information inside this particular serializable also. Okay, so this is coming from the which package? IO package. Getting the point. Now we'll see this particular, the remaining interfaces what we are having, random access, clonable and serializable. These are all the marker interfaces we are having. We'll identify what exactly this particular interfaces will do, but to focus on the array list. Array list internally extending from this particular abstract list, and it is implementing from this particular list interface. So list internally, we already identified is extending from the collection. Okay, so the hierarchy, it's clear. Now observe carefully default capacity. This is important here. What exactly it is doing default capacity? So what basically capacity is doing internally? It will try to give you the option to insert the element within this particular capacity. So we discuss here capacity is different, size is different. Getting the point? So this is important here. Capacity will give you the how many values we want to insert. And what about this particular size? The size will give you the how many elements are inserted into this particular array list. So currently how many elements we are having inside this particular array list here. So those information is going to provided by the array list here. And so capacity, how many we want to insert here. Okay, let me give you the diagram so that we can easily understand how this will work here. So capacity, this is 0 to 10. Okay, 0 to 10 we are having. This is the capacity. But size something like this is the size. The size basically, so size will start with the 1, 1, 2, 3, 4. So size basically 4 we are having, and capacity we are having 10. Now understand basically capacity we can insert up to 10 elements, and right now 4 elements we inserted. Okay, this is indicating as a size. So don't confuse it. This is important here. The differences between capacity and size. Okay, by default, how many elements we can insert here? 10. Okay, now if we observe carefully, where this particular data is inserting? Inside this particular object array. Okay, so whenever we are trying to work on this particular array list internally, again, it is trying to implement the data inside this particular object array. Okay, if you are aware of this particular array related section, we can easily understand how this particular array list is internally implemented here. Okay, so back to here, this is the empty object they are trying to create. So now you can see this is the array initializer. This is, we'll call it as a array initializer. We already identified earlier. Now empty element data they are providing here, and this is the one more default capacity empty element data. Okay, right now we are having so two object like array initializer, both are having empty. Both are having empty here. Now, if I'm going to move on the another important information, so we'll discuss here the object array. So this is the reference variable we are going to use here, and now you can see size. These are all the variables basically. Okay, these are all the whatever we discuss here. These are all the variables here. Now observe carefully. This is the constructor, because constructor name is matching with the class name. What exactly the constructor is doing here? Initial capacity. If you are trying to providing the capacity explicitly, what they are doing is they are trying to creating initial capacity. If it is greater than 0, they are making one condition. So now you can see what they are doing is object array. Okay, they are trying to create an object array. with the help of this particular capacity. For example, this capacity, if you provide as a 100, what happens internally? 100 object it's going to create it here. So something like 100 object array it is going to create here. Okay, 0 to 99. But any values it's going to insert here? Nothing, zero values. Nothing, zero values. By default, because it is an object, right? So it will try to insert the whatever we want to insert based on the type, it will try to provide the default values here. Now you can see if it is equal, the whatever the capacity we are going to provide equal, it is calling the empty element data. Nothing is inserted. And otherwise it is throwing an exception. Okay, this is all about the one of the important constructor. Now what you understand basically, so we are trying to create a one object like a element data where we created, this is the object array. Getting the point? This is the object array we have created, we are trying to inserting the values. Now this is we created one object array with help of this particular 99 size. Now this is the one more constructor, something like a default constructor. Right now this is the default capacity empty element data, nothing is there, so it is the empty. And collection, we can provide one more collection. Okay, this section we'll discuss later, because right now we could not understand what exactly this constructor will do. Now we identify the constructor information. Now I will move on to the one of the important method called add method, because we already familiar with this particular add method. We already familiar with this particular add method. First add method is coming from the collection, and the second add method is trying to come from the list interface. So al dot add method. Now whenever I'm trying to call this particular add method, how many method we are having? 4 method. First one is expecting string. Now it is trying to returning the boolean, and the second one is expecting 2 parameters, int comma string. It is not returning anything. Okay, add all. Okay, add all will returning the boolean, and the same add all it will returning the same boolean. Okay, 2 methods are coming from the collection, 2 methods are coming from the list interface, because now you can see indexes. Anything we are adding indexes information, this indexes related section is coming from the list interface. Okay, this is important. Now I'm trying to add this particular add method, which is coming from the our collection interface. So here I'm going to add the string information, something like AB, because what is the generic type we provided here? String we provided, so that we can add the string related section. Getting the point? This generic section we already discussed here. Now if I'm going to open this particular add method, now where we are inside the array list, so you can see here, we can see this is under the array list class. Okay, now understand here what happening internally. We are trying to call the boolean add method we are calling, and internally it is calling one more add method, is expecting 3 parameters. Okay, he is expecting 3 parameters here. Now if you see, this is the one more add method. This particular add method is coming from the list interface. This method is coming from the collection interface. Now finally what we are doing here, this is important, we need to understand. We are calling one more add method, element we are passing, element data we are passing, and the size we are passing. Observe carefully. So element data is nothing but object to the array we created. Okay, so right now with the help of this particular default constructor, nothing, there is no capacity. Okay, even though default capacity is 10, but object is not yet created. Object is not yet created. Okay, whenever I'm calling this particular add method, we need to understand here. We need to understand here. Now you can read this object to element data we are having. Now what we are doing is, we are trying to providing element data is a array type. S is indicating as a index here. Okay, and the particular E, whatever the E we are having, we are trying to do here. So we already discussed here single equal, the right side value, it's going to store in the left side here. So what is the left side we are having? It is a array type, because now you can see object array we are having here, and the reference variable we are having element data. Now finally what we understand here, so this is the using, we are trying to storing the element into object array. But now this is important here because this particular condition will satisfy length and s is equal to 0. Whenever it is equals to 0, now we are calling the grow method. The grow method is important here. How it is growing here? Size plus 1. Okay, size plus 1. Default size is 0. Now we are trying to add plus 1. Now I am calling grow. Now observe carefully. Arrays dot copy new capacity. The same method we identified here. Okay, arrays dot copy. Now what we need to understand here, we need to understand the new capacity. So using this particular new capacity we discussed in the last example, it is going to create the object information. Okay, it will return the capacity information here. This is the information we already discussed in the previous example, how this particular the array dot copy of find new capacity it is going to work. Now if I'm going to call this copy of internally, it will return the object information. Now you can see finally we are creating an object array. Okay, this is all about the simple add method. Internally, this is the structure we are having, how it is calling here. Now what I will do here, I'm going to call this particular add method and I will put a breakpoint. Okay, I will put a breakpoint here. So where I can put a breakpoint here, I'm going to put a breakpoint so that we can easily understand how it is working. This collection interface, what happens? Now I'm running in the debug mode. Okay, constructor is created, default. What we are having? Nothing. Array list? Nothing, because the capacity we are having 10, but we did not created any object array. Getting the point? This is important. Now I'm moving into the implementation method here. So now you can see we are calling the public boolean add e method. So we are inside the array list here. The top we can see we are inside the array list here. Now I'm calling mod count. What is the mod count right now? 0. Right now mod count is 0. So we are trying to use the plus plus. Okay, we are trying to use this particular plus plus here. Now finally add method I'm calling. So what is the size right now? Size 0. What about this particular element data? Nothing. Because element data so far we did not created any object here. We did not created any object here. So now you can see this is the E I'm calling. What is the E value right now we are having? Something like AB. Whatever we pass this particular AB, I'm trying to pass here. Finally, the grow like add method, internal add method I'm calling. Now you can see, yes, S is 0. Okay, S value 0. Why the S is not coming? Now S is 0 value. And if I'm going to check this element data dot length. Now what happening internally? It is also 0. Now this condition is satisfying or not? Because this is the first record we are inserting. Definitely this condition will satisfy. Once this condition will satisfy, now what we are doing is we are calling the grow method. Okay, whenever we are calling this particular grow method, now we are moving to the grow method. So size plus 1, size is 0. I'm trying to add plus 1. Now the size will become 1. Extend the screen. I could not understand your questions. The screen is already in the extended only. Okay, anyway, observe here what we need to understand here. This is the grow method we call internally. Now again one more grow method we are calling with help of this particular one parameter. So this grow method is not taking any parameter, and this grow method is internally extending with the one parameter. Okay, now I'm calling the same the grow method. Now you can see, so what is the minimum capacity we are having? 1. So minimum capacity. First, what we need to understand, the new capacity. Basically, new capacity, how much we are going to get here. If you understand this, we need to call the new capacity method. So I'm calling this particular new capacity. Whenever I'm calling, what is the minimum capacity we are having? 1. So what we are passed here? 1 only we passed here. Okay. So once we pass this particular 1, we are checking the old capacity. Old capacity is 0. Okay. And so new capacity equals to old capacity plus old capacity something. We are doing the some bitwise operations here. Based on this particular operations, we are going to get new capacity. So default capacity, how much we are getting? Now you need to understand. How much? 0. Okay. So you want to see this particular right side block. Now you can see here. Okay, so here you can see the minimum capacity, old capacity, and new capacity. Okay, now you can see. So what is the minimum capacity? New capacity is 0. Minimum capacity is also 0. And this particular condition will satisfy. This particular condition will satisfy. Like why it is satisfying this condition? Here we are using less than or equals. Okay, we are using less than or equals to 0. Whenever we are using this particular less than or equals to 0, so we need to check on this particular condition. Now you can see I'm moving into the 260 line number because the above condition is satisfied. Now what we need to understand here, we are checking this element data and the default capacity data. Both are same. Both are same. Right now we don't have any object information, so it will return true. Okay, it will return true. Now, whenever it is returning true, what we need to understand here? So once it is returning true, now what I'm doing here, we are trying to call this particular math.max. I discussed about this particular min and max method, which we already available inside this particular math class. Okay, so default capacity. What is the default capacity we are having? 10. And what is the minimum capacity we provided here? 0. Okay, so sorry, 1. With help of this particular grow method, we increase the 1. Now what do you understand here? So what is the max method will do here? Math.max method we are calling. So if I'm going to show you this particular max method, a value is a 10, b value we are passing 1. Now a value 10, b value 1. So a value is a bigger value, so that the a value will return. A value will return. Now we need to understand the ternary operator. This is very important here, the ternary operator. Okay, how we are implementing, because this is a multiple times I'm like explaining this particular ternary operator here. Okay, finally, what is the size, like what is the capacity we are getting here? 10. Okay, this section will return the 10. Now you can see the maximum capacity we are getting as a 10. Okay, so now we identify the capacity 10. Whenever we are getting this particular capacity 10, what we need to understand here, array dot copy of. So right now, nothing. The element data is not having anything. Now finally, this element data will contain 10 empty records here. Once I come out of this particular grow method, we can understand here. So 10 empty records we are going to get. Okay, I'm coming out of the grow method. Now you can see element data. Whenever I'm trying to providing this, now you can see because of this particular object, we are getting a null, but you can see 0 to 9. Okay, 0 to 9. Now what you understand here, whenever we are trying to insert the first record with the help of this particular first record, the default capacity is provided as a 10. Based on that, the 10 objects are created internally. It's like a one object array. How many elements we can insert? Up to 10. So inside this, the first record we are inserting. The 487 line number, we are trying to inserting first record. Okay. So after inserting this, now what I'm doing is, I'm trying to increase the size. What is the S right now? What is the S right now? 0. Now you can see here right side section, the variable section we can see. So this is the important section. Okay. The variable section is 0. Once it is 0, now what I'm doing here, I'm trying to increasing with 1. Okay. So this is all about the size, and finally if I'm going to provide the element data, now you can see in the 0 index location the AB inserted here. So the first record, AB is inserted. Okay. Now what you understand here? Array list internally, which concept is using? Arrays concepts only. Because we created one object array and each and every record we are trying to inserting into the object array. Okay. So this is the first method we call something like add method. Now you can see what happens internally. If I'm not getting anything is successfully, I'm trying to return true. Okay. I'm trying to return true because this is the Boolean method. This is the Boolean method. Okay. This is all about the add method. So finally it is completed. Finally it is completed. Now, so what happens internally if I'm going to print this? If I'm going to print AL, getting the point? The array list reference I'm trying to print here. Once it is saved here, I'm going to run this example. Now you can see AB I'm getting, but how I am getting this particular brackets here? Okay, how I'm getting this particular brackets here? So to get this particular bracket, what we need to understand here? ToString. Getting the point? We need to understand the toString information. So now, how we can write this particular toString information? To understand here, first we need to check whether any toString is implemented inside this particular array list or not. So nothing. Now you can see, right now we don't have any toString methods here. Getting the point? Right now we don't have any toString method. Now I'm trying to explain one more time. Now you can see we don't have any toString method. But where it is coming? Okay, from where this particular toString is implemented. So to understand this, first we need to go to the abstract list. Inside this particular abstract list, if I'm going to open, nothing. There is no toString here. Inside this particular abstract list also, we don't have any toString here. So from where it is coming? Again, the final class abstract collection. Okay, abstract collection. If I'm going to provide toString, now you can see here we are having toString method. Now you can read this, you will understand here. So it is appending this particular bracket and it is appending this particular closing one. Okay, this is the toString is implemented here. From the abstract collection, toString method is calling. Why it is calling the abstract collection? Because we are implemented the inheritance functionality. Okay, because of this particular inheritance functionality, first it will check the toString method in the list, like array list class. If it is not found, it will move on to the abstract list. If it is not found, it will move on to the abstract collection. So in the abstract collection, we identified this is the toString method we are having. Because of this, we are appending with this particular process, and the bracket is open and bracket is closed, and between whatever the value we are having. Okay, whatever the value we are having, we are trying to adding this. This is all about the simple example we discussed. This is the one of the array list is the implementation class for this particular list interface. Now what I will do, I'm going to provide the one more add method. So al dot add method I'm calling. Now I'm going to call the second method. The second method is expecting 2 parameters. So right now, how many object we can store? Up to 10 object we can store, because the default capacity is at 10. Now what I will do, I'm trying to give the 11 here. Okay, I'm trying to give the index as 11. The element, this particular element I'm going to give as a CD. Okay, I'm trying to give as a CD. So what happened? Why this is slow? Now you can see this println statement I'm going to print outside of this particular second add method. Second add method. Okay, so again I'm going to debug the code for the second method purpose here, so that we can easily understand what happening internally. Okay, let me run the same example. Let me run the same example here. Oh, this is very slow. Okay, so array list add method. This add method we already discussed here. I don't want to explain one more time. Now we are moving into the second add method. Here, the first parameter we provided as a index. In the 11th index, I'm trying to add this particular CD value. Okay, this is important here. Now I'm trying to provide the debug mode here. Now I'm trying to move on to this particular add method. But observe carefully, range check for add. Why we are checking this? Getting the point? This is important here. Why we are checking this particular method? So why we did not check here? There is no range check here. Getting the point? This is very important here. Whenever we are trying to work with a index related method, any index related method, first we are going to check the range. Whatever the index value we are providing, the value within the range or not, we are going to check here. Any method, you can check any index related method, any method we are going to check this. Okay, now I need to check this particular range check here. What is the index we are passing here? 11. Okay, so now I'm moving into the range check. Now you can see, so size, what is the size right now? 1. Okay, observe carefully, what is the size we are having? 1. And what is the index we are having? 11. What happens internally? This condition is satisfying or not? This condition is satisfying here. Getting the point? This condition is satisfying here. So now, whenever it is satisfying, what happens internally? We are going to get an exception. Now, what you understand basically here? If I want to, I don't want to get this particular exception, what I need to do? We need to give the within the size. Getting the point? We need to give the value within the size. But right now, the value, it is out of size. Size basically 1. Okay. The index we given as a 11. So observe carefully, here we are not checking any capacity. Okay. The second method, we are not checking any capacity. Capacity is different. Size we are checking. So right now only one record we inserted here. Okay. Because of this, we are throwing an exception. So index out of bounds exception we are going to get, and it will return this particular method for this particular message here. Okay. Index and size. Okay. This is a method. Now you can see, if I'm going to come out of this, you can easily understand here, index is 11 and size is 1. Index is 11 and size is 1. So this is all about the index related method. We need to be very carefully whenever we are writing it. Now what I will do, so I will call this first. Okay. First I will call this particular the index related method, and I will give you only one here. Okay, I will give you one. So we need to be, why this is very slow? Now observe carefully. Again I'm going to debug the code. Again I'm going to debug this particular code. So observe carefully what we need to understand here. This is the constructor we are creating here. Now I'm calling the same add method. Okay. Again we are checking the range. So again I'm trying to move on to this. What is the size right now? 0. Right now size is 0. Okay. If you give the 1, again we are throwing an exception. Again we are throwing an exception. Now what you understand basically, even for the first record also we are getting an exception. So see, for the first record also we are getting an exception. Okay, for the first record also I am getting an exception. This is what we are missing. Any idea what we are missing here? Why the first record also we are getting an exception here? So we are giving the size as a 1 here. But what is the value we should give? 0. Because indexes are start with 0. Okay, even we can go for the add method, which is expecting 2 parameters, index comma element here, but we cannot give the 1. If it is a first record, we should give as a 0 comma something like some value, because it will start with 0. Getting the point? Now whenever you are giving the 1, again it's going to throw an exception here. Okay, let me try with a 0. Now you can see here we are getting index is 1, size is 0. So if I will give 0, now we are not going to get any exception. So here I am running the same example one more time. So constructor is called, the method I'm calling. Now I'm checking this. Now you can see size is 0, index also 0. Okay, greater than is not going to satisfy, and less than also it's not going to satisfy. The value we should be -1, so that we'll get an exception, and more than 0 if you provide, we'll get an exception. Okay, now you can see we are coming out of this particular exception block. We are not throwing any exception. So mod count is 1. Okay, here you need to understand very carefully. Here if you see, we are doing the lot of expressions here. Inside this particular condition, we are trying to write the lot of condition. So first we are checking, like this dot element data, whatever the element data we are having, I'm trying to initializing into this particular element data. First step this, and the second one, the size, whatever the size we are having, I'm trying to pass into this particular size. Now I'm checking this. S is equals to this particular length. S is equals to this particular length. Finally, condition will satisfy. Finally, condition will satisfy. Why it will satisfy? Because is a empty records. The size and element data both are will match here. Both will match here. Because as of now we did not insert any record here. So the length and the size will become 0. Now if you see, yes, S will contain 0. Okay, and this particular element data is also empty. Element data is also empty. Okay, now I'm calling the grow method. So this grow method, just now we discussed about this particular grow method. Now if I'm going to call this, now you can see size plus 1 we are calling. Again we are calling the arrays.copy and new capacity. So here what is the value we are going to get? 10. New capacity we are going to get as the 10, and by default 10 records we are going to create it here. So I'm going to come out of this because we don't need to discuss more about one more time the grow method. Now I'm coming out of this. Now if you read this element data, you will get as a 10 records. Okay, 0 to 9. Okay, 0 to 9 is nothing but 10 records we are getting. Why we are getting the 10? Because the default capacity we provided as a 10 here. So once we provided, we are copying this. So as of now, nothing is there. So no need to copy this, but in the future references, this will work. Right now, it will not work. So now you can see the last one. What is the element we are having? What is the element? CD. Okay. And which index we are trying to replace here? In the 0 index here. And what is the element data? It is a object array. So once I come out of this, now in the 0 index location, we are inserting CD value. In the 0 index location, we are inserting this particular CD value. Okay, so we are increasing the size. So right now the size is 1. Earlier it is 0. Okay, so now you can see this particular array still it is 0, and this particular array now it is 1. Okay, so S is the size is now 1. So this is the way of writing this particular. This is the way of writing the add method, and one more add method which is expecting 2 parameters. Any questions here? So far we discussed this particular 2 methods here. Anyone having any questions? Okay, so if we don't have anything, so I'm going to stop the session, because we'll continue tomorrow. We'll try to discuss about the another method we need to discuss here. Here, along with this particular collection method, I'm going to cover the list method. So what is the method we discuss here? This is the method we discuss add method, which is expecting 2 parameter. Along with this, we identified the where is the add method? This is the method. Okay, so 2 method we discussed it. So we'll try to continue the remaining method in the tomorrow session. Okay, so this is the collection framework is one of the important example we are discussing it. So try to attend the daily session so that we can understand very clearly what exactly the collection framework is implemented. The internal structure, basically internal structure is important here. So once you identify the internal structure, we can easily understand how the each and every the classes and interfaces are going to work. Okay, so we'll continue tomorrow.